Hello everyone, let's solve LeetCode problem number 198 today. So first let's read the problem. We are a professional robber and we can rob the houses along the street. So we are given such an integer array which represents the profit we will get for robbing each of the house. So the only constraint for us is like if we robbed one house, we couldn't rob the adjacent house next to it because otherwise it will automatically contact the police. So we want to find out our maximum profit for tonight without alerting the police. So the best way to understand this problem is by looking at the example. Here I have a chart prepared for you, which is this profit array. And for each of the house at index 0, 1, 2, 3, we have the choice to rob it or not. So if we start from index 0, we can choose to rob it or not rob it. If we choose to rob index 0, we couldn't rob the house at index number 1, right? So then here we don't have any other choice. But then at index number 2, we can choose again, we can rob it or we don't rob it. And for this pass, we couldn't rob the last house, so we are done. But for this part, we can again choose to rob the last house or not to rob the last house. So for each of the parts, we can calculate the profit we will get. And similarly, I calculated the profit we can get if we choose not to rob the first house. So as you can see here, our maximum profit is 4, which means we robbed the index number 0 and index number 2. So here, let's look at this chart in another way. In order to find out our maximum profit at index 0, we need to find out the maximum profit at index number 1. And then we need to find out our maximum profit at index number 2. And in order to get it, we need to get the maximum profit at index number 3. Yeah. So if we start from here, for each of those parts, our maximum profit is 1, right? And then for this index number 2, for this route, since we are not robbing the last house, the profit we get is its own profit. And then for this part, since we are robbing this house, we couldn't get the profit at index number 2, we are getting profit 1. And we can calculate it like this, and finally we can calculate back to index number 1, index number 0, and we can get our maximum profit. So this is a quite straightforward recursion logic, so let's try to code it up. So we will define a function which will return a maximum profit we can get at certain index. So we will call it profit, and we want to pass in this vector by reference, and also we want to know where are we currently at. So I will define an integer house. And now let's first think about our base case. So if our house is bigger than, not cost, but nums.size, which means we are out of bound. So this means like we are at this position and we want to rob the next house, but we don't have any house here. So what we can get is 0, right? So here we can return 0. And then we can code up our choice part. So at each index, we can choose to rob the next one. We can choose to rob it or not rob it. If we rob it, we couldn't rob the next one. So the profit we get would be the current index profit plus the profit at the index plus 2. Yeah? But if we don't rob the current index, we can choose to rob the next one. Yeah? Or we don't rob it. So the profit would be the profit of index I plus 1. So here we can do this like this. This means if we rob the current index, so the profit we can get is our current profit plus the profit for index number 2. This is house plus 2. Great. And the second option would be if we don't rob the current index, and we wouldn't get this profit, but we can start from house I plus 1. Yeah. So finally, we want to return the maximum number of profit 1 and profit 2. Perfect. So now let's try to call our function profit nums 0. Okay, let's see what will happen. Great, we pass the test case, and if we submit, okay, we get this time limit exceed. Let me copy this test case, and you notice that in this chart, as you can see, if we look at this index number 2 here we have to calculate once what's the maximum profit at this index, but here when we reach it again from another path, we need to do the duplicated calculation, right? So if this tree grows very big, our complexity will be extremely high. So what we can do is we can memorize the maximum profit we can get at each index, and once we meet such a repetitive or duplicated index, we can return the profit directly without calculation. So let's code it up by using a memorization. So I will use a hash map here, but you can also use a vector if you like. This is, I will call it memo, it doesn't matter. So here I would just first store the profit we can get. So here should be house and 0, yeah? House number and the profit. And I will copy this. So here what we will return is just the house and this, yeah. So here we can return our house, our profit. So since we already calculated it here. And now what we can add is we can check whether we have already calculated the profit for a certain house. So we can do it easily by use the find function of C++, and if we already calculated this house, we can do it like this, and here we will return memo house. Great. Let's see whether our logic is correct. Great. I think we are done and we can submit our answer. So as you can see, this algorithm is not super efficient. So let's see whether we can do better. So actually the answer is yes, and it's pretty simple. As you will notice, we can just change our logic here to a simple dynamic programming logic. So basically, if we don't have any house to rob further, which means out of bound here, we can just put our profit at 0. And then for those each house, we can calculate our maximum profit like this using a dynamic programming equation. So this is exactly same as our recursion logic here, but we are just doing it like in a way like a simple calculation. So for this house, the maximum profit will be its own profit and the sum of its own profit and the profit at index 2 and this profit index I plus 1, so this is 1. And for this house number 2, the maximum profit would be the sum of its own profit plus this index, which is 3, or this one. So it's 3, and we can calculate it like this, and we can get our maximum profit is for at this index number 0. So let's code it up here. I will comment it out. And we don't need that function above. I will comment it out later. But here, let's first code up our logic here. So I will first set up our size, the size of our dynamic program array, DP array. So we need 2 more index, so I will do size plus 2, and then I will define our DP array. So great. Then we can code up the out of boundary part. This is 0, the last two index of our array, right? This is also 0. Then for the next part, we can start from the index number n plus 3, which is the last house in our vector, and we will do it until the index number 0, I minus minus. So this part would be quite simple as we already have our equation, yeah? So the maximum profit of our current profit plus what? Plus I plus 2, right? So this would be I plus 2 and our dp I plus 1. So I think we are done. Here we can simply return dp 0. Great. So as you can see, let me comment this part out. We don't need it anymore. So as you can see, this equation is actually just exactly the same as the logic here. So that's why I always like to write the recursion solution first. Let's run it. Great, we passed it. And now we can submit our answer. As you can see, this solution is really efficient because we are running through our vector only once. Our speed complexity is O of n. And we are using a dp array which is also size n. So our memory complexity is also O of n. So I think we are done for this question, and thank you for watching and see you next time.